Halle, now let's talk a little bit about your research, how you're assessing the vulnerability of the crabs to climate change via your modeling, and maybe you could comment on kind of the baseline historical research, your research, and areas that you think might require further ongoing research.
I'm using a vulnerability assessment framework, which is just a way that we can integrate information from a lot of different sources to kind of say how vulnerable we think the crab is to these stressors. And the specific framework I'm using breaks it down to the life stage level. And we do this by estimating first, what is the consequence of being exposed to these stressors? So what happens when a life stage is exposed to low oxygen or low pH? And then second, how often are they currently or in the future being exposed to these conditions? So for example, if you have a life stage that is very susceptible to a stressor, that actually won't matter if they're never going to experience those conditions. So you need to know both of those things in order to say something about their vulnerability. And to be more specific about the methods, I'm using an ocean model, which is made for the Washington and Oregon coast. And it is able to realistically simulate the present conditions along that coast. And we can also forecast it into the future to say what the conditions will be like at the end of the century. And I use those projections within the habitat of the different life stages to calculate the exposure of the life stages to harmful conditions. And then in order to get at the consequence of exposure, I use a literature search. So I'm looking at what experiments have been done to kind of say how high of a consequence exposure would be for each life stage. So for example, I can share with you my consequence for pH, which is here. So consequence we score from 1 to 3, with 1 being no effect of exposure and 3 being a lethal effect, just shown in red here. So we have each of the life stages on the left-hand column, their exposure score, and why I scored them as that. So you can see for the juveniles and adults at the bottom here, there's no effect demonstrated after being exposed to low pH, whereas for the younger life stages, we do see some effects. So for the eggs that were exposed to low pH, they had delayed hatching. The zoea, which is that first larval stage, had decreased survival. And then the megalopa, which is the last larval stage, had some effects on respiration and calcification. So I do that for each of my stressors using what's been already done. And it also highlights where future areas of research are still needed. So when I do this for oxygen, I find that there haven't actually been any studies exposing eggs or that first larval stage to low oxygen, so that we can make guesses based on other species, but in order to definitively know, we'd have to have those studies done.
So those studies might be future research?
Yeah. So that's one of the things I'm also interested in, is doing some of these experiments if I have time. I do have a couple of the adult Dungeness crabs that I was able to get shipped to me from the West Coast. And I'm interested in looking at their oxygen consumption in relation to different stressors to kind of see what the metabolic effect of the stressors will be on them. So for instance, for hypoxia, we know from that video and from other observations that the crabs have a lethal response to hypoxia, but we don't know the exact threshold limits for them. And we would need an experiment to say what those are. So then we could inform management, like, hey, maybe you shouldn't be fishing if the oxygen levels are this low.
You can perform some of that research with the live crabs there at Avery Point?
Yeah, we have a seawater lab out here, so we have them in tanks, and we can manipulate the water chemistry to create hypoxic conditions. And then we can look at, you know, their mortality, but also just their respiration response, and kind of make some guesses about what those thresholds are.
Okay. And you were telling me that I was asking you what you're going to do after graduation this spring, and you had a couple of thoughts. Would you share those with us?
Yeah, so NOAA and Sea Grant have some really great fellowship opportunities for postgraduate students. So one option is to continue this research as a PhD student. So they have a NOAA Fisheries Fellowship that I applied to, and that would allow me to continue to do some of this research to get a PhD. And through this work, I've also become more interested in management and policy. So they have a coastal management fellowship, which would place you in a state coastal management zone for 2 years. And there's different projects with that. And then finally, there's the Canals Marine Policy Fellowship, where you're actually brought to DC for a year and you work with either the legislative or executive branch.
Okay, great. What about if we go all the way back to the beginning? You've grown along the way with these different experiences in your educational life and so forth. What sort of advice would you have for, let's say, high schoolers and undergrads that are pursuing a science career?
Yeah, so I would definitely say that if they have an interest in research, to get hands-on experience as soon as possible through an internship or some sort of research opportunity like I did in college. And I think those experiences are very important for making sure that research is actually right for you. And there are also other things within science that you can explore through internships beyond just classes. I think those are important for understanding what you want to do after high school or after college.
And Halle, in closing, before we go to Q&A, what about our audiences always ask us how they can get involved? What can they do? Are there any actions they can take? Can you comment on that?
Yeah, so I actually have this great infographic that I can share with you all. So this was created by NOAA and National Marine Sanctuaries. They created an ocean acidification toolkit with the Dungeness crabs as a case study, and part of that was creating this infographics saying, how can you help? So we have, this problem of ocean acidification, and we know that it may make life more stressful for Dungeness crab life stages, and also for their prey. So we're expecting to be some sort of effect on the crabs. And this is especially important because the crabs support industry and livelihood of coastal communities. So they have these 4 ways you can get involved. So the first is choose to use less energy by burning fossil fuels. So this is talking about your carbon footprint and also on legislative. So find out what your local government, schools, and businesses are doing to reduce use of fossil fuels, and also transition to clean energy. So supporting those businesses and, government individuals who are supporting the fossil fuel switch to renewable energy. And then you want to educate others about how this is impacting ocean life. And finally, you want to support research like I was talking about today to inform management decisions that will best protect the Dungeness crab and other species in the future.
Great, that's a great infographic, Halle. Well, it's been a pleasure having you as our guest this evening. Thank you for your insights, and the great work you've done is very interesting, and we wish you continued success.
Thank you very much for that talk. That was definitely interesting, and I learned a lot. This is not a topic I'm familiar with. So I just had one question. You had a slide showing that the adults crabs are not affected by, was that hypoxia conditions specifically, or were we talking about all of ocean acidification in general?
Yeah, so that slide was just talking about ocean acidification.
Okay.
Yeah, so there's no effect when you expose crabs to just low pH. But we do know from that video we showed that there's an effect when you expose them to low oxygen. What's still unknown is what happens if they experience both low pH and low oxygen at the same time. Because there could be some sort of interactive effect where when they're combined stressors, it could actually have a larger effect.
Okay, but how long was that period of exposure to low pH? Is that because wouldn't that affect their shells?
Yeah.
Yeah.
So crabs in general have actually been shown to be pretty resilient to low pH and actually still be able to calcify because they can internally regulate their acid base and actually create an internal environment that is conducive to building their shell from the inside out. So they actually don't have an effect. And their shells are made out of chitin, which is more durable than just calcium carbonate alone.
Okay.
Yeah.
So it would not be sensitive necessarily, or not very sensitive to the prolonged exposure either?
Right.
Okay,
Yeah.
Thank you.
Thank you for your question.
Thank you.
Halle, is the Pacific Northwest the only place on the planet where there are Dungeness crabs?
Yeah, so just along the west coast of North America, yeah.
Okay, and do you see a lot of people studying them?
Yeah, so there are actually quite a few groups out on the west coast who are studying different aspects. So there's a NOAA lab group who is really interested in ocean acidification, so they've done a lot of those studies. There's also another group who has started doing the hypoxia work, and they're starting a motion of putting oxygen sensors onto crab traps so we can actually see what the oxygen conditions are at those crab traps, which is really interesting data.
Again, great job. We love having you on the Future Frogmen team. You're such a great asset, and you did a great job tonight. Congratulations again on all your hard work and continued success, okay?
Yeah, thank you so much, Richard. This was really fun.
Thanks for watching. For more information, visit our website at www.futurefrogmen.org.